Hi everyone. In today's video, we are going to discuss about linear programming problems. First, let us understand what do you mean by linear programming problem. Linear programming problem is a technique to optimize the profit or to optimize the cost. So when you look at a company which is manufacturing n number of products, for example, product A, B and so on. So here the company needs to find out how many number of product A, how many number of product B and so on. If I manufacture, I can end up in maximizing the profit or minimizing the cost as my objective function. There are certain constraints will be in place. The constraints may be on the resources, it may be an assembly line, it may be a machines. So based on those resources, how are we going to maximize the profit or minimize the cost? Okay, so the objective function can be of two. One is a maximum or to minimize. Okay, so maximize the profit or to minimize the cost. So this linear programming problems can be solved by various methods. The first of its method is graphical method. In today's session, we are going to discuss in detail and how are we going to solve by using a graphical method. Okay, so here the objective function is maximum z. So this is your objective function, and we have three different constraints. The first constraint, this is your second constraint, and this is your third constraints, and we have two variables, one is x1 and x2. These two are greater than or equal to 0. So now we are going to take equation number 1, okay, and we are going to substitute x1 equals to 0. So first equation is 4x1. So x1 we are substituting as 0 plus 6x2, which is equal to 360. So finally 6x2, which is equals to 360. So x2, which is equals to 360 divided by 6, which is going to be 60. So now we have to write the points. So this is to plot the points in the graph. So we need to have x1 and we need to have x2 for plotting the points. So x1 already we substituted as 0. So it is going to be 0, comma, and x2 we found out as 60. So the plot is going to be 0, comma, 60. So in the same equation, now we are going to substitute x2 as 0. Okay, so we are going to substitute x2 as 0. So 4x1 plus 4x1 plus 6x2. Okay, so x2 we are substituting as 0, so it is equals to 360. So now x1 equals to 360 divided by 4. So x1 equals to 90. So now we need to find out the points. So now points x1 is 90, x2 is 0. So now we have got 2 points for the first equation. So now we need to do the same for equation number 2 as well. Okay, so now take equation number 2. Okay, so in the equation number 2, we are going to substitute x1 as 0. So 3x1 is 0 plus 0x2, which is equals to 180. So now when we substitute this as 0, so this result 0 and this is also 0. So finally this value is entirely 0. So x1 and x2 both are 0. So the plot is going to be 0, comma, 0. So now we are going to substitute the same equation. We are going to substitute x2 as 0. So 3x1 plus 0 of 0, which is equals to 180. So x1 equals to 180 divided by 3. So finally x1 equal to 60. So now the plots are going to be x1 is 60 and x2 is we substituted as 0. So now we got 2 points to plot from the same equation. So now we are going to do the same for the next equation. So the next equation x1 we are substituting as 0. So 0 x1 we are substituting as 0 plus 5 x2 which is equals to 200. So x2 which is equals to 200 divided by 4, x2 which is equals to 40. Okay, so x1 is 0 and x2 is 40. So now we are going to do the same for equation, same equation. We are going to substitute x2 as 0. Okay, so 0 x1 plus 5 x2 we are substituting as 0. So finally it is going to be 200. So finally this value is going to be 0 because this is also 0, this is also 0. So 200 divided by 0 is 0. So now the points are going to be 0, 0. So now we found out the points by using your 3 different constraints. Okay, so we used 3 different constraints and we found out all the points. So now it's a time that we have to plot it in a graph. Okay, so now we are going to plot this in a graph. The first point is 0, 60. Okay, so 0, 60 is on the x-axis it is 0 and on the y-axis it is 60. So 60, 0, 60 will be over here. The next point is 90, 0. So on the x-axis it is 90 and y-axis it is 0. So 90, 0 will be here. So now we have to draw a line. Okay, so the line between these 2 points we have to draw. So the lines we have drawn. Okay, so now we have to mark the points for the next point, which is 0, 0. So 0, 0 comes here. So the next point is 60, 0 in that equation. So 60 on your x-axis and y-axis it is 0. So 60, 0 comes here. So now we have to draw a line. Okay, so here the first point is 0. So 0, 0. So from there we cannot draw a line. So now the line will be like this. From 60, 0 we have to draw a vertical line. Okay, so this is going to be the line for equation number 2. So the next one is we need to plot it for equation number 3, which is 0, 40. So 0 on the x-axis and y-axis it is 40. So 0, 40 and this next point is 0, 0. So 0, 0 comes here. So when it is 0, 0, you need not to use this particular one. So now we will be drawing a vertical line between these 2 points. Okay, so the line will be horizontal line between these 2 points. So the lines comes here. Okay, so now the next step is we need to identify the feasible region. So where my answers are lying. Okay, so that is going to be my feasible region. So how am I going to find out my feasible region? So here in this particular equation you have few things. Okay, so you have to notice what is the symbol that is coming here. Okay, so the symbol here is less than or equal to. Okay, when the symbol is less than or equal to, so your feasible region lies below the line. Okay, below the line the feasible region lies. Okay, so that is below this particular line the feasible region lies. If this is greater than, that means that it is the feasible region is above the line. Okay, the feasible region is above the line. Okay, so now we are going to find out the feasible region for this particular graph. Okay, so for first equation the feasible region is less than, so it is below this particular line. So I am marking, I am shading the portion below this particular line. So my feasible region for this equation lies below this particular line. And for the second equation, okay, so the feasible region is lying here. Okay, for second equation this is the feasible region, and for the third equation the feasible region is below this particular line. So this is equation number 3. Okay, so this is equation number 3 and this is equation number 2 and this is equation number 1. Okay, so the feasible region lies like this. Okay, now we need to find out exactly where is my feasible region, because here I have three different lines, but the intersection is where we consider as the feasible region. Okay, so here where the intersection happens, that is three different lines where we are having the intersection. So when we try to find out the intersection of these three different lines, it lies in this particular region. So where you could see all the shadings are there in this particular region. Okay, so this is where the intersection happens. Okay, so the intersection points, I'm just marking it as A, B, C, D and E. Okay, so I'm marking this particular graph like this. Okay, so now I need to find out these values. Okay, so wherever I have put this points A, B and C, so I'll be having the points like A, okay, which is 0 comma 0, and for B it is 40 0 comma 40, and E it is 60 comma 0. But for C and but for D I don't have the values. So how am I going to get these values? For C, which are the lines which are intersecting here? So there are two lines which are intersecting, equation 1 and equation 3. When you solve the equation 1 and 3, we will get the point for C. Same way for D, there are two intersections, one is equation 1 and equation 2. When you solve equation 1 and 2, we will get the point D. So finally we can substitute that in the objective function. Okay, so first we have to find out what is the point for C and D. Okay, so for solving the point C, we need to solve the equation 1 and 3. Okay, so let us write the equation, which is 4x1 plus 6x2, which is equals to 360, and second equation is 3x1 plus 0x2, which is equals to 180. Okay, so now we need to solve this equation. So for this, what I am going to do is I multiply this equation with 3. So I need to make these two values as the same. So I need to do a cross multiplication of this x1 value. So I need to multiply first equation with 3 and second equation with 4. So finally it results in 3 into 4 is 12x1 plus 18x2, which is equals to 1080. Okay, and this results in 12x1 plus 0, which is equals to 720. Okay, so when I subtract these two, okay, these two get cancelled, and this is going to be 18x2, which is equals to 360. So finally x2, which is equals to 360 divided by 18, so finally it is 20. Okay, so we found out x2, so x2 is 20. So now we have to use x2 and find out x1. So you can substitute in any of these equations so that you can easily find out what x1 is. Okay, so we'll take equation number 1, so which is 4x1 plus 6 into 20. Okay, 6 into 20, which is equals to 360. So 4x1, this becomes 120. So 120 goes that side, it is going to be minus 120. So finally x1 equals to, this 2 becomes 240 divided by 4. So finally it is going to be 60. So the point is 60 comma 20. So we got point C. The same way we have to do it for point D as well. Okay, so for point D we have to solve these two equations. So let us write the equations. So 4x1 plus 6x2, which is equals to 360, and second equation is 0x1 plus 5x2, which is equals to 200. So now we cannot make x1 as equal, so we need to make x2 as equal, because this value is 0, so we cannot make x1 as equal. So now we are doing a cross multiplication based on the value of x2. So find what you're going to do is you multiply this equation with 5 and this equation with 6. So finally this results in, so when you multiply this with 5, it is 20x1 plus 30x2, which is equals to 360,000, 500,800. And the second equation you have to multiply with 6, so this is going to be 0 and this is going to be 30x2 equals to 200 into 6, which is 1200. So finally if you subtract these two, okay, this is going to be get cancelled, so this is going to be 620x1, 20x1 equals to 600. So x1 equals to 600 divided by 20, which is going to be 30. Okay, so first we found out x1 is 30. Now we have to substitute x1 value in any of the equations so that we can find out the value of x2. So we'll use the second equation. Okay, so x0 of 20, this is going to be 0. Okay, 0 of this is 20, this is going to be 0, and 5x2 which is equal to 200. So finally x2 which is equal to 200 divided by 4, which is 5, which is going to be 40. So x2 value is going to be 40. So now we found out point D as well as point C. Okay, so now all the points are here. So what we need to do is we need to substitute those points in the objective function. Okay, so we need to substitute all the points in the objective function. So first the objective function is 15x1 plus 10x2. So first point A is 0, 0, so which is 15 into 0 plus 10 into 0. Okay, so finally this value is going to be 0. Okay, and for the next one it is going to be next one it is going to be 15 into 60 plus 10 into 0. Okay, so this value is going to be 900. Okay, and for this it is going to be 15 into 60 plus 10 into 20, so which is going to be 1100. Okay, and for this next one 15 into which is 30, so 15 into 30 plus 10 into 40. Okay, so this is going to be 450 plus 400, which is going to be 950. And the next equation is 15 into 0 plus 10 into 40. So finally this is going to be 400. Okay, so now we need to find out the objective function. The objective function here is maximum z. Okay, so here the value is 0, 900, 1100, 950 and 400. Among these values the maximum value is 1100. Okay, so finally max z, that is the maximum profit that you can attain, is 1100. Okay, when you have x1 as 60 and x2 as 20. Okay, so that means x1 products you have to manufacture 60 numbers and x2 products you have to manufacture 20 numbers, so that you can attain a maximum profit of 1100. Okay, so this is how you have to interpret the results. So this is how we are going to solve the linear programming problem by using your graphical method. Okay, so let's see you in another video. So I'll share you the content as well. So let us meet in another video. Until then, see you. Bye bye from Santosh.